Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, Safety and Concurrency. In the high-stakes world of quantitative finance and DeFi, execution speed and data integrity are paramount. Existing systems often fall short, leading to increased slippage, reduced profitability, and unacceptable risk. This lesson details why I chose Rust to rebuild my core trading engine, focusing on quantifiable improvements. My previous engine, like many, suffered from performance bottlenecks due to its reliance on a garbage-collected language. Specifically, unpredictable garbage collection pauses introduced unacceptable latency in order execution. Moreover, safely managing concurrent access to market data and order books was a constant source of headaches and potential race conditions, impacting trade accuracy. Rust's strengths directly address these issues. Its zero-cost abstractions mean you pay only for what you use, eliminating garbage collection overhead. The borrow checker enforces memory safety at compile time, preventing data races and enabling truly fearless concurrency. This allows for highly parallel execution of complex trading strategies without compromising data integrity. Reddit users have questioned the relevance of concurrency safety in HFT. But as systems become more complex, requiring multi-threaded operations, this becomes invaluable. Switching to Rust resulted in a significant reduction in average execution latency. We observed a drop from 89 microseconds to 12 microseconds, mirroring results other firms have seen abandoning Go. This translates directly to improved fill rates, reduced slippage, and increased profitability, especially when competing for liquidity depth. Rust's memory safety features eliminate entire classes of errors that plague other languages. The borrow checker guarantees that data is accessed safely across threads, preventing data races and corruption. This improved safety has reduced debugging time and increased confidence in the system's reliability during periods of high volatility. Beyond the core engine, Rust allows for the efficient integration of AI. Custom-built agentic loops, written in Rust, can react to market events in real time. These loops can leverage private RAG systems, also built with Rust for optimal performance, to access and process proprietary data for informed decision-making. This is critical for alpha generation in 2026's hyper-competitive landscape. Rust's concurrency primitives, such as channels and mutexes, facilitate building highly scalable trading systems. The async, await syntax enables non-blocking I/O, allowing the engine to handle thousands of concurrent connections to exchanges and data feeds. This scalability is essential for handling increasing data volumes and trading activity. Start by profiling your existing system to identify latency bottlenecks. Focus on rewriting critical components, such as order execution and market data processing. In Rust, leverage existing Rust libraries for finance, such as those for fixed protocol handling and time series analysis. Implement rigorous testing and benchmarking to ensure performance and safety. Continuously optimize your agentic loops and RAG pipelines for maximum alpha generation. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.